Alright guys, welcome back to our part 4 video of our immune system and lymphatic system. Alright, so if you haven't already, make sure to go in and check out part 1, 2, and 3. Alright, so in our part 3 video, we left off right here. Pretty much we finished off talking about the fact that our B cells present our antigen, our helper T cells and B cells work together and actually cause proliferation of each other into memory helper T cells, effector helper T cells, memory B cells, and plasma B cells. And then we said these plasma B cells start producing a bunch of antibodies, and these antibodies will then flow in the one-way direction that our lymph flow takes place, right? It'll flow one way and out eventually into the thoracic duct, right? It can flow into the right lymphatic duct also, but most of the time it's going to flow into our thoracic duct, then to our left subclavian vein, then to our superior vena cava, and then get dumped into our heart and dumped into circulation. Once it gets dumped into circulation, we said the free-floating antibodies, right, are dumped into circulation. So it's going to come back here on the arterial side, and it's going to be actually enter the area of havoc, wherever the pathogen is. It's going to enter through the endothelial cells and into the area. All right, in this process of squeezing through the endothelial cells and getting into the area and the tissues so it can help fight off the pathogen is called diapedesis. All right, so diapedesis. Okay, so that's the mechanism in which our free-floating antibodies squeeze through the endothelial cells, the endothelial lining of our blood vessels, and get to the area of infection, all right, or wherever the pathogen is. And we said we would see how in this video. So what happens is that our mast cell, right, can actually bind to our pathogen. So our mast cell can actually bind to our pathogen and actually release. So our mast cell can bind to our pathogen and release, so into our tissues. I'm just writing over here for room, right? And we can release histamine and another important chemical called heparin. Now histamine will lead to so let me go and draw an arrow back here. All right, so histamine will actually cause increased permeability, all right, of our endothelial cells. So I should say in endothelial cells, all right? So what I'm trying to say, right? I'm going to write this out first, endothelial cells. So what I mean by that is that now materials from the blood can actually pass much easier through and into the tissues. Not red blood cells though, just things like antibodies, right? Antibodies and neutrophils. So neutrophils floating in the blood or traveling through the blood can also now squeeze through via diapedesis due to histamine. And heparin can lead to, in the blood, it can act as a anticoagulant. So what it can do is that it can help inhibit some clotting factors like factor 2, right? Factor 2, factor 9, and factor 10, all right? And factor 10. So heparin can help inhibit some of these factors. So that's why heparin can act as an anticoagulant. All right, so it's mainly because, sorry about my voice there. So it's mainly because of histamine that our endothelial cells can become more permeable to bigger structures in our blood to cross through diapedesis, like antibodies and even neutrophils. All right, so even neutrophils can actually cross through and go to the area of infection. All right, and here we also see that some of the proliferated effector helper T cells, a few of them can actually also travel through and get dumped into circulation and eventually can enter through our endothelial lining and enter into the area of where our pathogens are. All right, so some of our effector helper T cells can do that also. Now, our B cells, right, most of our B cells actually stay here also, and same with our T cells, just a little bit of our T cells can go into the area of pathogens, right, the area of infection. The reason why our B cells, though, most of the time just stay here, because we already produce antibodies. So our B cells are already doing the work here. Antibodies go ahead and do the rest of the work here and help our immune system fight off the pathogens, all right? So that's actually a cool thing that can happen between our lymphatic system and our immune system. So just remember, if someone asks you, right, about the lymphatic system, it's not only a place where we can, it doesn't only play a role in reducing edema, right? If our lymphatic system wasn't there, it would be swelling up all over the place, right? And not only plays a role in that, it's actually a huge it plays a huge role in the immune system, because our lymph node, so this is our lymph node right here. Our lymph node is where most of the adaptive immune system takes place. So adaptive immune system takes place, and some things in our adaptive immune system are the cell-mediated response, so dealing with the T lymphocytes and the cytotoxic T cells and all that. So cell-mediated response, and our humoral response, so dealing with our B lymphocytes. All right, so cell-mediated response involves our T lymphocytes, right? And so like our memory T cells, helper T cells, effector helper T cells, right? And T lymphocytes, cytotoxic T cells, which is a class of T lymphocytes. Humoral response is mostly our B lymphocytes. Okay, and so yeah, this is what I wanted to get through in this video, is that we pretty much went over the fact that how histamine plays a huge role in letting things like antibodies, neutrophils, right? Antibodies, neutrophils, and things like some of these effector helper T cells to squeeze through and enter the area in the tissue wherever the pathogen is creating this havoc through diapedesis. And we talked about how lymph flow in our lymphatic vessels one way, and how this lymph node acts as a filter, right? As a filter, it cleans our lymph, And the reason why I say cleans is because it acts as a filter right here in our lymph node, right? It's fighting off pathogens, right? And then the fluid that leaves from here is actually less dangerous in terms of us talking about pathogens, right? Bacteria and viruses. So this is what I wanted to get through in this video, right? I hope this video made sense to you guys. Again, we covered many important things about the immune system, like heparin release from our mast cells, dendritic cells, how our dendritic cells actually connect the non-specific innate immune system to our specific adaptive immune system. Then we talk about lymph node, how important that is in terms of adaptive immunity, like our B cells and T cells. And we didn't show it here, but we have a video on this where we talked about it, that our T cells can actually bind to our dendritic cells, right, with its alpha beta T cell receptor. And then our dendritic cell can actually release interleukin 1, right, and help activate our T cell. And then our T cell can go find a B lymphocyte. And then many of these effector helper T cells, remember we talked about, can release interleukin 2, right? So it activates other cytotoxic T cells and other memory helper T cells, and keeps these B cells proliferating. Right, we talked all about that in our previous immune system videos. All right, but that's it. That's all I wanted to get through in this video. I hope this video made sense to you guys. I hope to see you guys in my future videos where we'll talk about more cool topics about biochem, physics, and chem. Don't forget to hit that notification bell, like, and subscribe. See you guys later, and stay safe.